All right, let's work through another one that was from your 4.2 activities. So again, if you have that solution, you can look back at the slope field and visualize the solution curves now that we'll have a general solution. So as usual, we want to move all of our y's to the left with the dy and all of our x's to the left or to the right along with our dx. So I'm just going to start by moving the dx. I'm totally happy, if you do all the rearranging in one step, that's fine. But just as we're getting used to playing with this notation even a little bit more than we were before. Sorry, dog attack again. It's apparently a terrible dog day. Okay, as we're getting used to this, I'm just going to do it one step at a time. So I want my y's on the left, my x's on the right. My x's are already on the right, so I need to get rid of the y plus 1, and I'll do that by dividing. X minus 2. Oops, what am I doing? It's still on the bottom. Dx, get out here, dog. Dx over x minus 2. Okay, and then as soon as you've got it separated, you can integrate. You do not want to integrate before you have it separated. So for example, in that first line, no go, because I can't integrate the right-hand side when there's y's and I'm integrating with respect to x. Okay, so I need the antiderivative of 1 over y plus 1, which will be a natural log absolute value y plus 1. Remember, that only works if it's first power in the bottom. If you want to, you could sub out the y plus 1 and turn it into 1 over u, but that one's simple enough that I also think it's okay to just guess and check your way out of it. ln absolute value of x minus 2 on the right-hand side and our arbitrary constant. Okay, so now we need to solve. So to get rid of the natural log, I'm trying to solve for y. I'm going to exponentiate with the base of e. So I'm going to say e to the left-hand side is equal to e to the right-hand side. And be really clear that you can't just go e to the natural log x minus 2 plus e to the c. It's e to that whole thing. Can't distribute the base, basically. So on the right-hand side, I'll have an absolute value of y plus 1, and on the left-hand side, I'll have e to the natural log of the absolute value of x minus 2, and then I am going to use an exponent property and say when there's addition in the exponent, that's the same as multiplying, and working backwards is usually the easy way to check that. If you have e to the natural log x minus 2 times e to the x, then when you mush that together, the rule says to add exponents. So that does match up with where we started. This e to the c, c can be any real number. If we're raising e to that power, we're still getting infinitely many different possible constants there, but they can't be negative and they can't be 0. When you raise e to the power, you're only going to get positive answers. So I think I will actually use a different letter there. I'm going to call that k. Okay. Also notice that we have e to the natural log of stuff. Because those are inverse operations, we can just say that's absolute value of x minus 2. Those two will knock each other out. Okay, so again, simplified. Now we want to focus on the left-hand side. I need to get rid of an absolute value. And the way to do that would be to say, okay, well then y plus 1 is plus or minus k times absolute value of x minus 2. And once again, I can kind of absorb this and I can write that in a simpler way. I don't need to leave the plus or minus. I can just say that's now, I don't know, n. So y plus 1 is equal to n times absolute value of x minus 2. Oh, and I didn't write this down, but do notice k has to be positive. Now that we put a plus or minus on that, n can be positive or negative, but it can't be 0. So n is any real number except for 0. Okay, so last step, I'm going to subtract that 1. And that's my solution, again, where n can be anything but 0. I don't think I really picked on you about keeping track of that, but if you're taking differential equations and getting into this a little more, you will want to be able to keep track of your constant. So if you look back at the slope field for this one, you should see those V shapes fit really nicely. So these are all going to be absolute value graphs, V's. And they're all going to have a corner at +2, -1. And then the n will determine whether the V opens up or down and how steep or flat it is. So that's what we're getting on that one. Okay, thanks for watching.